Hello, students. How are you today? And happy April 7th. So, we're going to start with our do now, and we have a prompt about those challenging conversations that we sometimes have to have with each other. So, that's our do now. Our objective today, we're going to factor trinomials of the form, so trinomials, three terms, and the form of the trinomial that we will factor today is the form x squared plus bx plus c. Our essential questions are: how can I factor trinomials? And how can finding a greatest common factor help me factor trinomials? So we'll be doing that with some of the more challenging ones that we work on. Our assignment will be to complete the do now, the 2 work pages, the exit ticket, and since everyone is distanced today, all work should be submitted on Teams. Your homework tonight is homework 7, factoring trinomials of the form x squared plus bx plus c. And don't forget, on Friday, we have a quiz. The quiz is all simplifying polynomials. We'll get back to our exit ticket in a minute, but we'll start with our do now. So, certain conversations can be particularly challenging, such as politics, religion, racial injustice, and gender equity. Those are sometimes hard conversations to have. Yet, challenging conversations such as these often lead to equitable solutions that help everybody. So, when you're having a challenging conversation, what's a way that you can build up your own opinion without tearing the other person's opinion down? That is a real hard thing to do. And I notice it's especially hard when you're a teenager. Your opinions are so strong and you believe so firmly in them. But if you're going to have a successful, challenging conversation, you're going to need to learn to listen to the other point of view and try to hold your tongue a little bit while you're listening to them and do some active listening. That's a hard thing when you're talking about some of these challenging topics. So if you have any strategies you can think of for doing that, please answer those there. Good question today in the do now. So we're going to start with a little bit of a warm up. We've got 3 binomials, 2 binomials being multiplied by each other. And so we're going to simplify them right now. So we'll use FOIL, first, outer, inner, last. So x times x is x squared. X times 5 is 5x. So that's a positive 5x. 1 times x is a positive x. And 1 times 5 is a positive 5. When we combine like terms in the middle, we end up with x squared plus 6x plus 5. So let's look at the second problem. So we're going to look at m minus 4, m plus 6. So m times m is m squared. M times positive 6 is positive 6m. M times negative 4 is a negative 4m. And negative 4 times positive 6 is a negative 24. When we combine those like terms in the center, we end up with m squared plus 2m minus 24. So we end up with a trinomial. And then the third one, we have k minus 7, k minus 3. So we have k times k is k squared. K times negative 3 is negative 3k. Negative 7 times k is negative 7k. And negative 7 times negative 3 is a positive 21. When we combine like terms, we end up with k squared minus 10k minus 21. So as we work through these problems, I want you to pay special attention, even looking at this warm-up, at the signs. With the first binomial set, we have positive and positive, and our answer has positive and positive. With the second binomial set, we have positive and a negative, or a negative first, then a positive. And our answer has a positive first and a negative second, a negative on the constant term of 24. With the third set, we have two negatives, and our answer ended up with two negatives. So as we work through the problems today, I want you to look for patterns such as these that can help you with these binomials. So let's get back to away from the highlighter, and I'm going to use the blue pen for a while. And we're going to start, we're factoring today trinomials, three terms of the form x squared plus bx plus c. Now here's the trick, here's the rule. You must find two integers, so that can be positive or negative numbers, no fractions, no decimals. And these two integers must add to b, and we're talking about the b term in the trinomial, and those same two integers, not two different integers, those same two integers must multiply to c. So they're going to multiply to the c term. So add to the b term and multiply to the c term, but the same two integers. So let's look at some examples, and let's get started. So we have x squared plus 7x plus 12. So the first question is, what two integers have a product of 12? So they're going to multiply to 12 and add up to 7. So we're just looking at the b term. Well, those two integers would be 3 and 4. Now, we're going to write two binomials using these integers, and then we're going to distribute to check our work. So we're going to write x plus 3, x plus 4. They're plus because these are positive integers. Now, if we multiply or FOIL this binomial set of binomials together, we have x squared plus 4x plus 3x plus 12. When we combine like terms, that leaves us with x squared plus 7x plus 12, which is where we want to be, back at where we started. This means that this answer checks. So we're factoring trinomials using this trick where we find two integers that add to b, the b term, and multiply to the c term. Be mindful of the signs and be mindful of those invisible ones as we work. Now we've got four sets here. Set 1, set 2, set 3, and set 4. We'll get to the mixed practice later. I want you to notice that with set 1, we have both of our terms, our second and third term, are both being added in every single one in the set. In set 2, the first term and the second term are added together, and then the constant at the end is being subtracted. And that's true in every one in set 2. Now in set 3, the second term is subtracted from the first term, and then the constant is subtracted. So we have two subtraction operations in the trinomial. And in set 4, we are subtracting the middle term from the first term and then adding the constant at the end. So we have subtraction and then addition. So as we work through these problems, I want you to think about the relationship between what we are presented with in terms of those operational signs and how we end up once these are factored. So let's get started. So for number 1, we have n squared plus 9n plus 20. So what two integers add up to 9 and multiply to 20? So that would be 4 and 5. They add to 9 and they multiply to 20. So we start with n, so that would be n plus 4 multiplied by the quantity of n plus 5. So now if we were to distribute, to FOIL, which is a form of distribution, if we were to FOIL this back together, we would have n squared plus 5n plus 4n plus 20, and we would combine the like terms in the center, giving us n squared plus 9n plus 20, which means that our answer checks. So this is what we're looking for. So number 2, w squared plus 9w plus 18. We need two integers that add to 9 and multiply to 18. So we're going to try 6 and 3. So w plus 6 multiplied by w plus 3. And if we FOIL this expression, we will end up back where we started. So in set 3, we need two integers that add to 10 and multiply to 24. So 5 and 5 add to 10, but they do not multiply to 24. 7 and 3 add to 10, but 7 times 3 is 21. However, 6 and 4 add to 10, and 6 times 4 is 24. So that's our solution. So it would be a plus 6, a plus 4. And if we were to FOIL this expression, we would end up with a squared plus 10a plus 24. So let's look at number 4. So we need to add to 2 and multiply to 1. Well, that would be 1. So we would have y plus 1, y plus 1. Now, when we end up with two binomials that are the same, we can rewrite them as y plus 1 squared. And this will FOIL back to the original trinomial. Now, set 2, we have n squared plus 3n minus 18. So we need to really think careful about the signs on the integers that we choose. So what will add to 3 and multiply to 18? Well, 6 times 3 does multiply to 18, but it adds to 9. However, if I were to make the 6 positive and the 3 negative, then they add to 3 and they multiply to negative 18. So, and then I write n plus 6 times n minus 3. And let's go ahead and FOIL this. I'll change the color. So n times n is n squared. N times negative 3 is negative 3n. 6 times n is positive 6n. Positive 6 times negative 3 is a negative 18. We combine like terms in the center, and we have n squared plus plus 3n minus 18, and our answer checks. So here's our answer. So now you're going to have to pay special attention to the positives and negatives. So for number 6, x squared plus 2x minus 8, we want two numbers that multiply to 8 and add to 2. Well, 4 times 2 are 8, but we want a negative 8, so one of those has to be negative. So we know we're going to have a 4 and a 2. So how can we combine, which one of these should be negative in order to get, well, either one can be negative in order to get the negative 8. But only one of them can be negative in order to get a positive 2, and that would be the 2. So we're going to have a negative 2, because if the 4 were negative, we would end up with negative 2 here, and that's not what we want. We want positive 2. So now we're going to write this x plus 4, x minus 2. And that's our final answer. So for number 7, we have an invisible 1 here. So we want our numbers to add to 1 and multiply to 6. Well, 3 plus 3, 3 times 2 is 6. 6 times 1 is 6. And that's how the only two ways to get to 6, and one of those would have to be negative. But we've got to add to 1. So that's going to be the 3 and the 2. And we know one of these is going to have to be negative. So that would be the 2, because if you add 3 and negative 2, you're going to get a positive 1. If you multiply 3 and negative 2, you will get a negative 6. So those are our numbers. So we start with G plus 3, G minus 2, and that's our solution. And then finally, number 8, 6 squared, c squared, plus 4c minus 45. So I need two numbers that add to 4 and multiply to 45. So we can get to 45 15 times 3, but we cannot get to adding to 4. But we also have 9 times 5. So if we take 9 and 5, if one of them is negative, either one can be negative, we will get to negative 45. But which one needs to be negative to give us a positive 4? Well, the 5 will have to be negative. If we add positive 9 and negative 5, we end up with positive 4, which is where we want to be. So c plus 9 times the quantity of c minus 5 is our solution. Now you can distribute any of these, and you will end up where you started, which is c squared plus 4c minus 45. So let's look at some more examples. Let's look at set C. Now, set C, we have two subtraction operations in each trinomial. So let's see, we're still same rules. Add to B and multiply to the C term. Okay, that hasn't changed. So if we want to add to negative 2 and multiply to 3, the only way we can multiply to 3 is with a 3 and a 1. If we want a negative 3, one of those will have to be negative, either one. But if we want to add to negative 2, the only way to do that is for the 3 to be negative, because negative 3 and 1 is negative 2. So now it would be a minus 3, a plus 1, because the 1 is positive. So let's FOIL this. A times a is a squared. A times 1 is a. Negative 3 times a is negative 3a. And negative 3 times 1 is negative 3. We combine like terms in the center, which gives us a squared. Negative 3 plus 1 is negative 2a. We have our negative 3 constant, so our answer checks. So this is the correct answer. So number 10, two numbers that add to 7 and multiply to 30. And I think of 10 times 3, 15 times 2, 6 times 5. But the only one that gets me to 7, somehow I can use the 10 and the 3. And if I want a negative 7, then I'm going to need the larger one to be negative. So negative 10 plus 3 will give me that negative 7 that I need. And negative 10 times 3 multiply to negative 30. So x minus 10x plus 3 is our answer. Number 11, I need two numbers that multiply to negative 63 and that add to 2. So I'm going to need two numbers that are pretty close to each other that add to 2. I can get to 63 with 9 times 7, and one of those numbers needs to be negative to give me a negative 63. If I want a negative 2, then I need the 9 to be negative, because negative 9 plus 7 will give me that negative 2. So then I just write b minus 9 times the quantity of b plus 7. And then number 12, I need these numbers to add to 12 and multiply to 64. So you might need to play with this a little bit with your calculator, 8 times 8, but that's not going to get me to 12. But I can do 16 times 4. Now, one of those is going to have to be negative. If I need that negative 12, I need that larger integer to be negative. So negative 16 times 4 will give me that negative 64, and negative 16 plus 4 will give me that negative 12. So I'm good to go. So now I've got k minus 16 times the quantity of k plus 4. And that's our final answer. Now, in our last set, we have one final iteration of adding and subtracting. We're subtracting the middle term and adding the constant at the end. So we're subtracting this middle term and we're adding the constant at the end. So let's think about how this could work out. I need two numbers that add to 11, negative 11. So I need them to add to negative 11 and multiply to positive 24. Well, there's two ways to get a positive number. You can have a positive times a positive, or a negative times a negative. So right now I know that both of my terms are either going to be two positive terms or two negative terms. But think about this. I need them to add to negative 11. So two positive terms are not going to add to negative 11. So that tells me in order to have that negative number in the center, I need to have a negative times a negative. Okay, so what two numbers, negative numbers, add to negative 11 and multiply to positive 24? Well, 8 times 3 is 24, and negative 8 plus negative 3 do equal negative 11. So I'm looking at x minus 8 and x minus 3. So let's FOIL this out. I'll change the color. So x times x is x squared. X times negative 3 is negative 3x. Negative 8 times x is negative 8x. And negative 8 times negative 3 is a positive 24. I will combine like terms in the center to get x squared minus 11x plus 24. And our answer checks. So let's look at the next three. You should try them on your own and come back to the video if you'd like. So I need two negative numbers to add to 14 and multiply to 49, and that's pretty easy. We're going to have negative 7 times negative 7 and negative 7 plus negative 7 to give us our negative 14. So that would be x minus 7 times x minus 7. Now, where we have the same binomial repeated like that in multiplication, I can rewrite that as x minus 7 squared. And that is our final answer. If you FOIL that out, you will be back at x squared minus 14x plus 49. So number 15, I need two numbers that add to negative 17 and multiply to 72. And I can get to 72 with 9 times 8, 36 times 2. But the way to get to 17, that 9 plus 8 equals 17. So if they're both negative, negative times a negative is going to give me that positive 72. And if I add negative 9 and negative 8, I will get negative 17. So let's write our answer. Y minus 9 times y minus 8. And that's a final answer. And then number 16, m squared minus 15m plus 50. So how did I get to 50? Well, 25 times 2, but that won't help me with that negative 15. How about 5 times 10? So 5 times 10 will get me to 50, but if I want them to add up to 15, they both need to be negative. So negative 5 plus negative 10 is negative 15, and negative 5 times negative 10 multiplied to 50. So let's write this one out. M minus 10 times the quantity of m minus 5. So you getting it so far? I hope so. So let's try some mixed practice. So I'm going to mix it up a little. So for number 17, we'll do 17 through 22. We have positive, positive, and then a negative. The constant is subtracted. So we're going to have a positive and a negative number in our parentheses. And that's according to, you can compare that to set 2, okay? So you can go back and look at set 2. So this is very much like set 2. So multiply to 16 and add to 6. So we can get to 16 with a positive 8 and a negative 2, or a negative 8 and a positive 2. But if we wanted to add to 6, it will have to be 8 minus 2. So that would be a plus 8 multiplied by a minus 2. And if you FOIL that, you'll be back where you started. So number 18, I need two numbers that add to negative 14 and multiply to negative 72. And I do know that 18 times 4 is 72. And if I want them to add up to negative 14, I'm going to need the 18 to be negative. So that would be x minus 18, x plus 4. Okay, and this one is, is very much like set 3. Okay, this is like set 3. Oops, put that in the wrong place. Okay, next one, we have two positives. This is like set 1. So we need two numbers that add to 13 and multiply to 40. So I know that 10 times 4 is 40, but that won't get me to 13. But I do know that 8 times 5 is 40, and 8 plus 5 is 13. So this is a little bit of an easier one. So that would be y plus 8 multiplied by y plus 5. And now number 20, I need two numbers that multiply to 48 and add to negative 16. 24 times 2 would get me to 48, but that would not get me to negative 16. But 12 times 4, negative 12 plus negative 4 equal negative 16, and negative 12 times negative 4 would multiply to 48. So that's my solution. So I'll have w minus 12 multiplied by w minus 4. And number 21, I have an invisible 1 here in front of the n. It's a negative 1. So I need two numbers that multiply to negative 30 and add to -1. So I'm going to have a positive and a negative. So 10 times 3 is 30, but that's not going to get me to -1. 15 times 2 is 30, but that will not add to -1. But how about 6 times 5 multiplied to 30? One of them will have to be negative. Well, if I want this -1 here, that larger one will have to be negative. So I will have n minus 6 times n plus 5. And then number 22, two positives. I need something that adds to 6 and, adds to 13 and multiplies to 42. And I can do 6 plus 7 make 13, and 6 times 7 is 42. So that would be k plus 6 times k plus 7. Now we're going to challenge you a little bit. We've got 6 examples where we're going to have to pull out a greatest common factor first. And then we will be left with a trinomial. After we're left with that trinomial, we can go ahead and use our new skill to factor that remaining trinomial. So in the number 23, I have 4k squared plus 12k plus 8. So I cannot factor out any variable because a variable needs to be present in every term in order to be factored out. But I can factor out a 4. Now, if I factor out a 4, I'm left with k squared plus 3k plus 2. So 12 divided by 4 is 3. 8 divided by 4 is 2. Now, I need a number that adds to 3 and multiplies to 2. Well, that would be 2 and 1. So I would have, don't forget your 4 in the front. And that would be k plus 2 and k plus 1. And if you FOIL the middle and then multiply everything by distributing the 4 through, you will get back at the original trinomial. So number 2, 2x squared minus 8x minus 24. So I cannot factor out a variable, but I can factor out a 2, which will give me x squared minus 4x minus 12. So I need a number that adds to 4 and multiplies to 2. Notice I've got 2 negatives here, so my numbers will be negative and positive that I choose. So 12 is, I can do 6 times 2, and if the 6 is negative and the 2 is positive, they add up to -4. That's what I need. And they multiply to -12. So that would be x minus 6, not plus 6, x minus 6, x plus 2. And if you were to FOIL that and then multiply everything by 2, you would be back at your original trinomial. So number 25, again, we cannot factor out a variable, but we can factor out a 3, which would give us y squared minus 5y plus 4. 12 divided by 3 is 4. So now I have a negative and a positive in my trinomial. So I'm looking for 2 negative numbers that multiply to 4 and add to 5. So 2 times 2 multiplies to 4, -2 times -2, but they do not add up to -5. But if I do -4 times -1, that will multiply to 4, and that will add up to -5. So 3, we have y minus 4 and y minus 1, and that's our final answer. Let me circle or put a box around our final answers here. Okay, number 26. Now we have our first trinomial where we can factor out a variable as well. Let's factor out the 3. We can easily see we can factor out a 3, and we can also factor out an a, which leaves us with a squared plus 30 divided by 3 is 10, and we have our a left because a squared divided by a is a, and then we have 63 divided by 3 is 21, and a has been factored out. So now we will factor the trinomial a squared plus 10a plus 21. So I'm actually going to change color for that. So we have our 3a, and we need a number that adds to 10 and multiplies to 21, and they're both going to be positive. So 7 times 3 add to 10, and they multiply to 21. So it would be a plus 7, a plus 3, and that would be a final answer. If you FOIL the a plus 7, a plus 3, and then multiply that all by distributing the 3a through there, you will end up back at the original trinomial. Now, number 27, we have 2 addition terms. Again, we cannot factor out a variable, but we can factor out a 2, which leaves us with b squared plus 5b plus 6. 12 divided by 2 is 6. Now we need 2 numbers that add to 5 and multiply to 6, and that's pretty easy, that one. That would be 3 and 2. Excuse me, 3 times 2 is 6, and 3 plus 2 is 5. So 2b plus 3, b plus 2, and that's our final answer. You can check that by FOILing and distributing. And then finally, our last problem. We're going to factor out the 5, but what else do we have? We can factor out the y as well. So let's factor out the 5y, and let's see if we've got a trinomial that we can work with. So if we factor out 5y, we have x squared minus 3x minus 140 divided by 5 is 28, and the y has been factored out. So now we've got 2 subtraction signs. So our choice of numbers will be a positive and a negative. So we need 2 numbers that multiply to 28 and add to 3. We know that 7 times 3 is 28, and we know that if the 7 is negative and the 3 is positive, we'll get that negative 28 and negative 7 plus 3. I should have said 4, not 3, I'm sorry. 7 times 4 is 28, not times 3. Okay, and that negative 7 plus 4 equal negative 3. So let's go ahead and write our answer. We have the 5y. So now it will be x minus 7 and x plus 4. So take your time. Please, please do your homework. You absolutely need to practice these on your own to get good at them. And these are the skills we're going to be using in a couple weeks when we solve quadratic equations. So we want to make sure that we are fluent in this and comfortable with this before we work with quadratics. So let's look at our exit ticket to factor trinomials of the form x squared plus bx plus c. Remember, you can have plus or minus, okay? We state the formula with plus with addition, but either one or both could be subtraction or negative. You must find 2 integers that add to the b term and multiply to the c term. So good job today. I did put a little calm down activity. If you're feeling a little stressed, you'll see that. Here is your homework, homework 7. It's 1 page, 24 problems. And there's a fun little pixel art activity to do before you do your homework to kind of let you rest a little bit and relax, or if you feel up to it. I've got a word Sudoku. Be careful of the uppercase and lowercase s. They're very different, and you can fill in the word Sudoku. So good job today. I love how you're paying attention. I love how focused you are, and I appreciate your hard work. You're doing a great job. And remember, all you need to do is practice, and then you'll be great.